Hello and welcome to my Tech Fun. My name is Igor, and in this video I would like to cover topics like what is hardness, how to measure the hardness, what is Shore Durometer, how Durometer works, and I will explain with this 3D printed object. Main part of this video will be the review of two Durometers which are sent to me by Banggood for a review. And in the last part I would like to measure the hardness of some 3D printed materials. Okay, so first let's see what is the hardness. It is the property of material, the resistance of the surface to the mechanical indentation. This means if we want to measure the hardness, in that case we have to press different objects into material with known force and measure the penetration, and then we can calculate the hardness. I'm a mechanical engineer, so I'm familiar with the hardness of the metals. Hardened metal is more wear resistant. Maybe you are familiar with hardened nozzle, which is recommended to use with carbon fiber or glowing dark filament, which are very abrasive, because it will not wear so easily like brass nozzle. In mechanical engineering, which I'm familiar with, are different methods for measuring hardness of the metal, like Brinell, Rockwell, Vickers. They are very similar on using different force and different object to press into the tested material. For example, Brinell, it will use the ball. We have to press it with a given force and measuring the diameter of the hole, and from that we can calculate the Brinell hardness, the HB. Poldi Hammer, based on Brinell hardness, but it is a comparison test. Here we have this steel ball, and we need an ettalon, which is some metal with a known hardness. We have to place it inside, and then we have to place it on testing material, of course, which is metal, hit it with the hammer, and we will get two holes. One hole in the tested material and the other is in ettalon. Maybe some holes are visible already on this ettalon. It is full of holes. We can measure the diameter. Actually, in this set it is some small micrometer with a ruler of the 0.1 mm precision. And then using this equation we can calculate the hardness of testing material. The reason I mentioned this Poldi hammer, because I would like to test it at the end if I can use this method with plastic. Only of course I will replace this ettalon with some 3D printed material, which I will know the hardness, which I will measure with this durometer sent to me by Banggood. More about that later. Now, so far I was talking about the measuring hardness of the metal. Now, Albert Ferdinand Shore in 1930 had a patent apparatus for measuring the hardness of the materials, and I found it on the internet. Look at this beautiful drawing. Of course, from that it's a little bit harder to understand, but it has different scales, and for us most important are Shore A and Shore D. Shore A is for softer materials like rubber, or in our case TPU, flex filament, and Shore D will be for other plastic, PLA, PETG. So I have no idea what is the hardness of these materials, so it's a good opportunity to measure it. Now let's see how Durometer works, because it will be very important in our next step. So I 3D printed this part. Only 4 parts, so the blue is the body, the green is the indentor. This is some kind of spring which can be, I know, TPU. This is from PLA because it's elastic, and this white is just regular PLA. This is the gear for the scale. So now it is on the zero hardness, and if I press it with maximum, this is the maximum hardness. But of course, if you measure something which will be between, it is very important that it has to align on this surface, and it has to be perpendicular. For example, I will show you. If I press it under the angle, you can see there is a difference in measurement. So it is very important to, when you press it must be aligned completely on this surface. For best precision, it is recommended to use it with some stand or something like that, and which will give this exactly the vertical movement. Like this, but you cannot see. Actually, I can see in few months maybe on eBay somebody will sell this, like measuring the hardness of the body or fat or something like that. And you know, it wouldn't be the first time. I already saw my designs on Kickstarter. I'm not sure is it completely mine, but spherical dice. I redesigned the original design, and now I can see it's on Kickstarter. I don't care, but it would be good to get some attribution if it is really used, my design. Okay, let's move on. Now we know how Durometer works. Of course, this is very simplified version, just to understand how it works, but this mechanism is much more complicated with this Shore Durometer. And of course, the spring must be very precise, very known force, and the indentor, shape of the indentor is also very important, and this gives us different scales for Shore diameters. Let's see what I have here. Two Shore Durometers from Banggood. And theoretically the one is the Shore A and the other is D. Yes, this one is A and this one is D. So this is for rubber, for example. So with this I can measure TPU or flexible filaments, and with this the rest of the plastics. Actually, the two scales overlap, so I can see that rubber, for example, this is printed with TPU, and it is Shore 95 A hardness. This means it can be measured with this one, but it is recommended that if it is above 90, then use the next one. So that would be, I don't know, somewhere between 40 or 50 on a Shore D. So actually, if you want to buy only one, in that case I will recommend you to use only this one, the D, for 3D printed materials. So these two durometers are sent to me by Banggood for a review. And I'm very happy that I got two, because with this, as I mentioned, I will measure the flex filaments, and with this the rest of the plastic. I can see here some user manual, and in the description you can see some instructions how to use it. You can use it in some stand or from the hand, but it is important that the material align to this, and the thickness should be at least 6 millimeters. The battery has to be inserted here, I think. No. This should be the connection for the data cable, probably. And yes, here goes the battery. Okay, let's try to find some. And it's working. This is the on-off button. Here I can zero it, and this is the hold button. If you measure somewhere which is not so comfortable to read it, press the hold button, and then you can read it comfortable when you face it to the screen to your face. This one is Shore A, and it is different, the indentor, and the spring is also softer, so I can easily press it with my finger. Let's insert the battery into the other one. And now this is the D for harder material, harder plastic, and it's very hard. I cannot press it with my finger. And this is sharp. The interior is much sharper. I try to make a closer picture of it so you can compare it. Now I want to measure some 3D printed plastic. My first idea, this was the closer, to measure this PLA, but I cannot do it according to the instructions. I need at least 6 mm of solid material, but this is printed with infill, so I need different test specimens for this. Just a quick example, this is Shore A for softer material. If I test it on this PLA, and first I have to zero it, and I press it completely down, surface aligned completely, and you can see the hardness is approximately 100 maximum. So this is too hard for this durometer, for Shore A. For this I need Shore D. It is zeroed, and now I'll press it completely down. 78 on Shore D. Actually, it's a little bit hard to press it with your hand, so definitely for this some kind of stand is recommended for more accurate measuring. And now it's time to test different 3D printed materials. And you saw that these durometers can be used from your hand manually. But for better accuracy and easier using, I will use this drill stand. I have it now for several years. I don't use it because I have a milling machine which I can use as a drill press. This is my metalworking corner, and what you see in video usually is this plastic corner. And I would like to test first is the direction of the printing and testing with the durometer has different effects. So I want to see if I test it in layer direction or perpendicular to layer, is there any difference? And then I will test these test specimens from one of my previous videos, because I got from Creality 6 different filaments: PLA, PETG, ABS, TPU, and I want to see is there any difference there. And then I believe with plastic the temperature has a big effect to the hardness. So I will place these test specimens in the silane filament dryer to, I don't know, maybe 40-45 degrees Celsius, and measure again the hardness. I want to start with measuring if direction of the printing has effect to the hardness. So as you can see, this is the direction of printing for these two test specimens. These are top layers, and I will measure in this direction. So here I will measure in direction of the layers, and here perpendicular to the layers. I believe this should be a little bit weaker, because sometimes the needle may go between two layers, and that will affect a little bit false measuring, but let's see. So I will start with this one, measuring between layers. I'm using the Shore D, and I will measure several times. 75.5, 78, 80, 71.5. Let's see the other side. 76, 77.5. I think I should wait a little bit. 71.5. And one last one. 77. That was in layer direction, and now perpendicular to layers. And I have two different sizes, because this one was on the bed surface and this one was the top layer. I will start with this on the bed surface, it's more smooth. .5, 79, 78.5, 79, 78.5, very constant as I predicted. And from now on, I will measure everything perpendicular to layers. So this is CR PLA from my previous videos. 78.5, 78.5, 79, 78.5, no, 78. So. Now this is Creality PETG. 71.5, 71.5, 71.5, 71. 70.5 and 71.5. So it's softer than PLA. This is Creality Silk. 75.5, 75, 75.5, 75, 75.5. And this is Creality ABS. 75, 75 point, so 75. 75, very constant. 75. 77, no, 76.5, okay. And this is nylon carbon fiber. 57. 64. 60.5. 51. 60. 57.5. 58. 48. I believe that this big difference depends where the needle hits. If it hits some carbon fiber,
then it is more harder. If it is between, then less, because nylon should be softer material. And now let's measure some resin. This is Prusa tough resin, also from one of my previous videos. 75.5, 75, 75, 75.5. And another resin, this is Iligu water washable resin, also from my previous videos. 67, no, 66. 66. I have to wait until the penetration ends. 65. 60, 65. And last. 65. And this is Creality TPU, and probably for this I have to replace the Shore type. This is Shore D, but let's try it. Theoretically, actually I don't know the hardness of this TPU, CR TPU. It's not on their website, but if it is approximately 95, then on this scale it should be around 40. So let's see. And I have to wait until the penetration stops, and it slows down now. I understand why they recommend a different type of the scale for the rubber. 39. 40. 41. Okay. And now I replace this durometer from Shore D to Shore A. And now measuring the TPU with the Shore A. From Shore D I can see some small spots from the needle, from the indentor, and here theoretically we don't have that spot. So if you don't want to damage your part, probably this is the better solution. 93, 96.5, 95, 93, 92.9, and 94.5. I will place some test specimens into filament dryer to see the effect of the temperature to the hardness of the most popular 3D printing materials. So I have here PETG, silk, ABS, and two types of the PLA. Maybe add resin. And now approximately after half hours the temperature inside is between 40 and 45 degrees Celsius, because this is not accurate here in the middle of the filament dryer. Let's start with the Creality PLA. 71, 70, 71.5. This is Gamebird PLA. 75.5, 74.5, 76. Silk, Creality Silk. 73, 70.5, 70, 1.5, 72, 72. PETG. 70, 75, 69.5, 70.5, 69.5, 69, 69. ABS. 72, 73, 70, 73.5, 74, 33. And the last one, Prusa tough resin. I think there shouldn't be any difference, but let's see. 75, 79, 79.5, 79.
So let's analyze the results. In first experiment I have that test parallel and perpendicular to layers, and I can see that this if I test it parallel to the layers I get smaller values sometimes, but that's not a bigger problem. A big problem is the standard deviation. Everything which is above 1 is a little bit problematic, and the reason is that sometimes the indentor hit between two layers. So definitely if you want to measure the plastic, always do perpendicular to the layers for better accuracy. In next experiment I tested these materials, And here you can see the hardness, and they can be seen here on this graph too. And here the standard deviation, which are okay in almost every case except the carbon fiber, and I explained that properly. The reason is that sometimes this needle or indentor hit the carbon fiber, sometimes between these two, so the hardness is not constant in this case. And last one was here the CRTPU, which was on Shore D40 hardness, and then I measured with Shore A durometer, and here I got 93.5 hardness. And then in next experiment I tested on higher temperatures, so I placed these materials into filament dryer on approximately 45 degrees Celsius, and I got this value as the standard deviation was okay in every case. And here they are. So this table, this is on 24 degrees Celsius, which was the room temperature in that basement, and this was the temperature approximately in the filament dryer. I didn't measure it accurately. And in every case, the filaments get smaller hardness, especially the PLA, except the resin. So the Prusa Tough resin, it was actually harder after this filament dryer. I'm not sure is this normal. If somebody is familiar with the resin, please let me comment.
Now let's see if we can use a Poldi Hammer to measure the hardness of the plastic. So I printed these parts. It is for 3D active PLA, and the cross section is same like with this Ethanol, the reference material. But in first step I have to know the hardness of this material, and I will measure it here on the bed surface. 37.5, 36.3, 35.5, 34.5, 35. And it doesn't scratch the surface, that's a good sign. And for the first test I will test with the same filament, and theoretically I should get 2 equal holes. Just 2 more. And just one last measuring. This is PETG, which should be softer than PLA. Only one spot I don't want to mark it because it's dark. So the PETG is softer and the hole should be bigger. I don't think this equation will work because it is theoretically for Brenner. But let's see.
Now I have to measure the diameter of these holes, but I will not use this small microscope provided with the kit, but I will use 2D scanner, which is much more accurate. For example, I will scan it with 600 dpi, that's dot per inch, and from that I can calculate the dimensions. I scan the picture with 600 dpi. And I can see the holes, but it's a little bit hard to see, so I try to use these pencils so they are more visible. Then I could measure, so this is in pixels, and I could calculate the dimensions in millimeters. So these hole pairs should be equal because they are same materials. And the PETG hole was a little bit hard to see because of that black color, but I raised the contrast, and then I could measure this hole too. And I enter everything into this Excel table. What I noticed that first 3 hole pairs has almost equal dimensions. This is a good sign because it was tested on the same materials. But when I calculate the hardness of the PETG, I got very different value from measured with the Shore Durometer. So the Poldi equation is only for Brenner hardness, and it does not work with the Shore hardness. At least not with this kind of equations. And now the conclusions. Well, first of all, if you want to measure hardness of the 3D printed plastic, always measure perpendicular to layers and not in direction of the layers. You will get more constant and accurate readings. Don't forget, hardness of the plastic depends a lot from the temperature, so always try to measure in room temperature, and well, at least record the temperature in environment during the measurement, because you can get very different values if you measure in the winter on, I don't know, 15 degrees Celsius, or on summer of 25 or maybe 30 degrees Celsius. In video I mentioned that if you want to buy only one Shore Durometer for measuring 3D printed plastic, then I would recommend the Shore D, this scale, because with this theoretically you can measure the TPU, the flexible filament too. But later, when I actually did these measurements, I noticed that it is a little bit hard to measure the rubber with this sharp indentor. It penetrates constantly, you have to wait until it completely stops, and it makes a small hole. So definitely, if you want to measure a TPU a lot, in that case I would recommend you to buy this Shore A for the softer material. And in last experiment I tried to measure the hardness with this Poldi Hammer, and it was very pleasant surprise to see those first 3 hole pairs are very equal with each other. So theoretically this could work, but when I tried to measure the PETG with this Poldi Hammer and use that equation and compared to that with hardness which I measure with Shore Durometer, I got completely different results, and that's normal actually, because these two scales, the Brinell and the Shore D, are completely different. So this method could work only if you know the hardness of the reference material in Brinell, and but nowadays nobody wants to measure the hardness of 3D printed plastic in Brinell. Everybody wants to know in Shore D scale. Well, that would be it. The Banggood only asks for review of the Shore Durometers, but I think now I can give you some complex picture about the hardness. Yes, again a long video, but there are no ads during the video. If you have some suggestions, what could I measure with this durometer regarding the 3D printing, then let me know in the comments. And also I would like to know, for metal, for example, I know that harder material is more wear resistant. I'm not sure if that's the case with the plastic too, and maybe there is a correlation with the hardness and yield strength or something like that. So if you have some ideas what could I measure, let me know in the comments. And that would be it from my side. Thank you for watching, and happy printing.